Hi everyone. Today we are going to look at how to answer paper 3 questions number 1. So let's start by reading the questions. Now an experiment was carried out to investigate the effect of different concentration of sucrose solution on the potato disc. So from here basically we can start to guess. Now perhaps the concentration of the sucrose solution will be the MV, and what happens to the potato disc should be our RV. Right, so this is our initial impression on the RV and MV. Then step number 1, a cork borer was used to obtain 50 potato discs of uniform size. Then the potato discs were divided into 5 groups, okay, P, Q, R, S, D. Each group contains 10 potato discs. Now, so whenever you see figures, and most likely they are the CV. So you need to make sure that you have 10 potato discs in a PQRSD set. And then number 3, distilled water and sucrose solution with different concentration was poured into each petri dish as shown in table 1. So you have your ND here. This is your ND. Alright, the first one being the distilled water, followed by 0.2 mole per decimeter cube sucrose solution, 0.4, 0.6, and 0.8. Then step number 4, the length of each group of potato discs was measured before the immersion by arranging the discs on a calibrated cupboard as shown in diagram 1. Alright, so you have 10 potato strips altogether. They are arranged side by side. Then you take the measurement. So this is 11.0 centimeter. So number 5, the potato discs were then immersed in each solution for 30 minutes. I see a figure here right now. It should be the CV. After 30 minutes, the discs were then arranged on the calibrated cupboard again. Then the table 2 shows the results. Now let's look at alright, so let's fill up the table first. When the concentration of the sucrose solution is 0, so what is the length of the 10 discs after immersion for 30 minutes? So this is 11.4 centimeter. I don't have to repeat it here. I don't have to, because it's already stated by the title. And then 0.2, I have 11.2 centimeter. 0.4, I have 10.6 centimeter. Then here is 10.4. Then I have 10.2. Alright, so from 11 centimeter, some of the potato strips increase in the diameter, some decrease in the diameter. Now A1, state 2 different observations made from table 2. So how do we answer these questions? Let's look at the template. Now, how to write an observation? Remember this framework. When the MB is state the value and the ORV is the highest or the lowest. Okay, the most important thing is you have to mention the unit, the value together with the unit for the ORV. So how we are to write 2 observations. So which 2 observations are we going to write? We have to choose the one with the highest and the lowest ORV. Right. So now come back to this. So my lowest ORV will be this, and my highest ORV will be this. So when 10 potato discs were immersed in 0.0 mole per decimeter cube sucrose solution, the length of the 10 discs. The length of the 10 discs are 11.4 centimeter. 11.4 centimeter. So likewise, I'm going to repeat the same sentence here, but right now it was immersed in 0.8 mole per decimeter cube of sucrose solution. So the length of the 10 discs are then 10.2 centimeter. Alright, so please note that I have my MV. I state my MV and I state my ORV with unit. Alright, so there must be value with unit. Then tick immediately, I get 3 marks. Then number 2, state the inference which correspond to the observations in A1. Also, how to write an inference? No, let's follow this template. The ORV is high or low because related to MV, and then we explain more about the MV, and as a result the RV is high or low. So what is my ORV here? My ORV is the length of the 10 disc. The length of the 10 disc after immersion of 30 minutes is the longest. Now this is because we have to relate it to the MV, because distilled water, or I can say 0.0 mole per decimeter cube sucrose solution is hypotonic to the cell set of potato strips, and thus more water molecules diffuse into the potato cells by osmosis. Remember, when we talk about the movement of water, we have to mention the word by osmosis. And as a result, we have to mention the RV. What is RV? If you do not know what is RV, perhaps you can look at E1. Now from these questions, you know that concentration of the sucrose solution is MV. The length of the 10 discs after 30 minutes immersion will be the ORV. This is what you measure. ORV is what you measure. Oh, sorry, this is your CV, because we make it constant at 11.0 centimeter, and then this is what you measure after the experiment, and the change in length is your RV. RV is what you calculate from your ORV. So the last sentence, I end it with the change. There is an increase in length of 10 potato strips. Good. Now my second inference should correspond to my second observations. So I will just copy and paste from the above, but this time I will say that the length of the 10 discs after immersion of 30 minutes is the shortest. This is because this time I have to state that 0.8 mole per decimeter cube sucrose solution is hypertonic to the cell set. Remember, when we use the word hypertonic, we have to compare to another solution. From once we compare a solution to another solution, to the cell set of potato strip of the potato cells. So thus, more water molecules diffuse out of potato cells by osmosis. As a result, I need to make a conclusion about the RV. There is a reduction in the length of 10 potato strips. Now in inference, what you want to mention is number 1, your ORV. This is your ORV, And then number 2, you need to relate it to the NB. And then if you have something to elaborate further, please elaborate, and finally make a conclusion about the RV. So as long as you have these 3 components, the MV, ORV, and RV, then you get 3 marks. Then B, record the length of the potato disc after 30 minutes immersion. Okay, so we have recorded it just now. Remember not to make any mistakes when taking the readings of the ruler. So if you got all of them correct, then you get 3 marks. Then number C, how to handle the variables. Now the MV, what is the MV in this case? If you forget, then let's refer to E1, concentration of the sucrose solution. Concentration of sucrose solution. And then how to handle? Remember the template. The template is use different MV. Copy and paste from E1. Use different concentration of sucrose solution, and if possible, try to state the example such as 0.0, 0.2, 0.4, 0.6, and 0.8 mole per decimeter cube sucrose solution. Now, by doing so, you have just earned yourself 2 ticks. Then responding variable. Now you can choose to give the ORV or the RV. Both are correct. So let's say I want to put the ORV here. What is my ORV? The ORV is the length of the 10 discs after 30 minutes immersion. Length of 10 strips after 30 minutes immersion. Now remember, this is ORV, so my behavior is measure. I may measure and record. I measure and record the length of 10 strips after 30 minutes of immersion using apparatus, using meter ruler. Now otherwise, I can choose to write RV. What is the RV in this case? The RV is the change in length. Change in length. Now, so what is my behavior? My behavior is now calculate and record the change in length of 10 strips after 30 minutes immersion using what? Using there is no apparatus here. We use formula to calculate the change using formula. So what is the formula? The change in length is given by final length minus initial length. Alright, so by doing so, you get another 2 ticks. Now last one, let's look at the constant variable. Where's my CV? As mentioned in the text before, we try to look for things with figures, with a fixed figures. Now, for example, here would be the immersion, okay, the immersion period or the time of immersion. So here the time of immersion. So how to control it? Now we say fix or use the same. So fix the time of immersion and then state an example. Okay, at 30 minutes. Okay, well done. Then you get 3 marks. If you get 6 ticks, then you get 3 marks. If you get 4 to 5 ticks, then you get 2 marks. If you get 2 to 3, then you get 1 mark. If you get less than 1, then the answer is, okay, the marks that you get is 0. Now D, state the hypothesis for this experiment. There are two templates on how to write a hypothesis. The first one is like this. If the MV is quantitative, the MV can be measured, then you use the first template as MV increases, RV increases or decreases. If the MV is qualitative, cannot be measured, then we use comparison method. Now let's look at it. So if you look at the concentration of sucrose solution, can it be measured? Yes, yeah, it can be measured. So I'm going to use the first template. As MV increases, as the concentration of sucrose solution increases, I can choose to write the ORV or the RV. So let's say the length of 10 potato strips after 30 minutes immersion. Immersion is decreases. Now please note that I try not to change the phrase used in the questions. I try to retain it. Now from E1, the concentration of sucrose solution is my MV, and then what is my ORV here? Length of 10 discs after 30 minutes immersion. Length of 10 potato strips after 30 minutes immersion. I try to use the phrase given by the questions. Try not to modify it. So what are the criteria? The criteria for D. Now number one, you need to state your MV, you need to state your ORV or the RV, and remember to mention the relationship or the direction. So as you can see here, this is my MV and this is my ORV, and what is the direction? Now this is my direction. Something increases, then this one decreases. So if you have all these criteria, then well done, 3 marks are given to you. Then E1, construct a table. Remember, this is a table, so please bring a ruler. You have to draw your table. Record all the data collected in this experiment. Your table should have the following titles: A, B, C, and D. Right, so that's not difficult. Let's start by drawing the frame. So let the first one be the concentration of sucrose solution, and remember to give a unit for it. This is measured in mole per decimeter cube. Make sure that you have a unit for it for the titles. And then you have the length of 10 discs before 30 minutes immersion. This is measured in minute. Sorry, length is measured in centimeter. And then followed by the third bullet point forms here. You have the length of 10 discs after 30 minutes immersion. Again, it is measured in centimeter. And finally, you have the change in length. You don't have to write a formula here. The most important thing is to state the unit, which is change in unit is centimeter. So I start from 0.0, 0.2, 0.4, 0.6, and 0.8. Okay, then let's transfer the data from the previous pages. So when it is immersed in distilled water, 11.4, 11.2.6, 11.4, 11.2, 10.6, 10.6, then 10.4 and 10.2, 10.4, 10.4 and 10.2. Now if you can recall how to calculate the change in length, it is the final minus initial length. So the final is 11.4 minus 11. So what do you get? You get 0.4, and this is 0.2, and then this is decreases. 10.6 minus 11, you get negative 0.4, negative 0.6, and finally you have negative 0.8. Alright, so how to mark these questions? First of all, make sure that you have the headings together with the unit. If you have them, then you get 1 tick, and then transfer of data. If you transfer the data correctly from the previous pages, then you get another marks, and finally calculation will give you another marks. Alright, so it is title plus unit 1 mark, data transfer 1 mark, calculation 1 mark. So altogether 3 marks. Then number 2, use the graph paper. This is E number 2. Use the graph paper provided on page 5 to answer this part. Using the data, draw a graph of what against what. This is my RV and this is my MV. So we were to plot the graph of RV against MV. So I'm just going to sketch it out. So since the change in the length has two parts here. One is positive values, the other one is negative values. So I have to divide my graph, okay, to two parts here. This is my change. This is the RV, change in length, and remember to put the unit here, which is measured in centimeter, and this is concentration of sucrose solution, which is measured in mole per decimeter cube. So we start from 0, which is distilled water. Alright, so when it is 0, so it is positive. It registers a value, a change in the length of 0.4. Let's say this is 0.2, 0.4, 0.6, 0.8. Okay, I just simply sketch it. But remember, when you plot it on the graph paper, make sure that you use the right scales so that your graph actually fill up at least 50% of the graph paper. When it is 0.2, then it is 0.2, 0.4, negative 0.4. 0.4 is negative 0.4, 0.6, negative 0.6, 0.6, negative 0.6, and finally we have 0.8, negative 0.8, negative 0.8. Then in biology, we don't have straight lines like physics. What we have is smooth curve. So I'm going to use a pencil to trace a smooth curve which passes through all the crosses. Then let's check whether we are able to get 3 marks or not. First of all, let's check the headings together with unit. Okay, well done. Then you get 1 mark. This is title, unit, and scale. Title, unit, and scale. You get another. You get 1 mark. And then number 2, you have transferred the data correctly. Data transfer, you get another marks. And finally, you have the smooth curve. Smooth curve, there is another marks. So the answer, the total is 3. So from number F, based on the graph, explain. My task word here is explain. So don't just state, you need to have F and E. Effect and explanations between the concentration of sucrose solution and the change in the length of the potato strip. So I have my MV and RV. So what can I say about this? As the concentration of the sucrose solution increases, then the change in the length actually changes from positive to negative. So first, I'm going to state the relationship. As the concentration of sucrose solution increases, the change in length of potato disc decreases. Okay, decreases. Then we are to explain it. Now in our second sentence, we try to relate it to the MV. This is because the sucrose solution is becoming more hypertonic to the cell steps of potato strips. So more water molecules continue elaborating about the NV diffuse out of potato cells by osmosis. Since more water diffuse out, then what can you expect? Now, okay, in the last sentence, you got to make a small conclusion here, which is the ORV. As a result, the length of the potato strip after 30 minutes of immersion decreases. Now let's look at the template here. The template. How to explain the relationship between RV and MV? First of all, we state the relationship just like writing a hypothesis. Then number 2, related to the MV, tells about how MV brings about the RV, and as a result bring a small conclusion about the ORV. The ORV is high or low. So let's see whether we have these 3 components. Okay, number 1, yes, this is a fact, I get it right. Then number 2, I have explanation, and I try to relate it to the MV. And finally, I have the ORV. This is my ORV. Good. So if you have all of them, the MV, RV, and ORV, then you get 3 marks. And number G, if the experiment is repeated using potato discs of the same diameter but different thickness, now you are given a brand new MV. So predict the change in the diameter of the potato disc. Explain your answer. So how do we explain your prediction? Explain your prediction. So first of all, I need to state my prediction. So predict the change in the diameter. So the change in the diameter of potato disc when immersed. I need to have a benchmark. Immersed in 0.8 mole per decimeter cube sucrose solution. Now in 0.8 sucrose solution, the change in the diameter is negative 0.8. Right now it is thicker, same diameter but different thickness. Now the question is rather confusing here, because we were told that the potato discs are of the same diameter, but they have different thickness. Okay, so I can just make a guess. Perhaps the rate of diffusion would be lower. So since the rate of diffusion is lower, so by right, the change in the diameter should be less than negative 0.8. Is less than negative 0.8 centimeter. Alright, so this is my fact. And then what is my explanation? This is because right now I need to relate it to the new MV here. The rate of water diffusion is lower in thicker potato strip. Then continue elaborating. Less water molecule diffuse out by osmosis per unit of time. That means to say that the rate is lower. And finally, as a result, since we have mentioned the RV and the MV in this case, so in my last sentence I should always relate it to the ORV, the final length of 10 potato strips is lesser than. Now of course you can say, just state, okay, you can just say lesser. It should be sufficient. If you want to make you want to compare it to a benchmark, then it will be better. So it will be lesser than 10. No, it should be greater than 10.2. Should be greater. Since less water diffuse out, it should be greater than 10.2 centimeter. Now let's check. You have the MV, RV, and the ORV with the correct prediction. Then well done, you get 3 marks. Let's see again. How do we explain a prediction? First of all, state prediction. Give a value with unit of cost. Then number 2 and number 3, try to relate it to the new MV. New MV is stated in the questions. And then lastly, give a small conclusion about the RV or the ORV. If in the first sentence you talk about the ORV, then the last sentence you should always end it with RV. If the first sentence you talk about RV, then the last sentence you should end it with the ORV. Okay, now H. Based on the result from this experiment, what can be deduced about osmosis? Deduce about osmosis, that means to say that we need to give an operational definition. Now let's see. Let's look at the template. Now, number 1, state the modified definition. Now in your second sentence, you should relate it to the ORV, and the last sentence, let's talk about the MV. So what is osmosis? Based on the book, osmosis is the net movement of water molecules only from a region of high concentration of water to a region of low concentration of water across a semi-permeable membrane. Now, which is, this is my first sentence, my second sentence, which is shown by the ORV. Now, what is my ORV here? The final length of 10 potato strips after 30 minutes immersion and is affected by concentration of sucrose solution. If you can't remember the MV, ORV, and RV, please refer to questions number E1. Now, so of course, you have just managed to get 2 marks here. When you say it is shown by the ORV, immediately you get 1 tick, and it's affected by the MV, another tick. Now let's look at the first sentence. Let's modify it so that it suits our experiment. Osmosis is the net movement of water molecules only, yes, from a region of high concentration of water. Now in this case, what is the region of high concentration of water? It could be the external solution of the cell set, right? So let's take external, yeah, from the external sucrose solution to cell set, and of course, or vice versa. If the external sucrose solution is hypertonic, of course, it's hypertonic to the cell set, but of course the movement of the water molecule is from the cell set to the external sucrose solution across a semi-permeable membrane. Now, what is a semi-permeable membrane? In this case, it is the plasma membrane. Across the plasma membrane of potato, not other vegetables or other plant cells. Okay, it is the potato the potato cells. All right, and so well done, you have just earned yourself 3 marks. Now another student wishes to investigate the movement of substances across the plasma membrane. He is provided with the following material. Now classify the materials above according to its permeability. So now in examination you will be given a table. So there are actually 3, okay? One is fully permeable, one is semi-permeable, and one is impermeable. Now a visiting tube is definitely semi-permeable here. Eggshell is fully permeable to all fluids. It is fully. Cellophane tip, since it is plastic, so I would say that it is impermeable to all fluids. Masking cloth it is actually fully permeable to all fluids, and plastic, it is again impermeable. So if you got all of them right, ticks, okay, 3 marks are given to you. All right, so hopefully you'll be able to score well in paper 3 questions number 1. The total marks are 33. There are altogether 11 questions, and each question carries 3 marks. So with this, thank you so much. All the best in your exam tomorrow. Thank you.